Hello folks, this is Melissa Johnston-Cota. I am one of the chemistry teachers in IB Chemistries at Capitol High School. This video is going to review for you how to write a quality lab procedure in chemistry, but it can also transfer over to many of your other science classes. First and foremost, why do we write procedures or methodologies in a science class when we're doing a lab investigation? So when a scientist performs a lab investigation, you would like, or the scientist would like, the results to be repeatable by the scientists themselves, but also the greater scientific community. By clearly defining your variables and adding as much detail as possible to your methodology or your procedure, your investigation becomes repeatable. Then others can support or refute your claim. Great example of this nowadays is our search to find a vaccine for COVID-19. So when one company comes up with a particular recipe for a vaccine by doing a particular lab investigation, that investigation has to be reproducible by other scientists. And it can't be unless that investigation is written clearly with clear, controlled, manipulated, and responding variables. So let's talk about those variables. All good lab investigation procedures include control variables, manipulated variables, which are also called independent variables, and responding or dependent variables. And let's start with the control variables. Definition, once again, of a control variable is a variable that stays the same during the entire investigation. So let's go back to Ms. Hall's balloon example from the CER video. So we're going to try to prove, is air matter? And Ms. Hall did that by taking the mass of a balloon before, filling up with air, taking the mass of the balloon after, and seeing that the mass went up. That meant that the air had added mass to the balloon, therefore air is matter. So if I was to write a procedure for that investigation, we could define some control variables as maybe using the same balloon, maybe using the same number of breaths to blow up the balloon, maybe filling up the balloon to the same volume every single time. There's that balloon example again that you might remember from Ms. Hall's video. So manipulated variables. Manipulated variables are also called independent variables, and that is the variable that you change during the investigation in order to measure a result. So identifying the correct manipulated variable depends on whatever investigation you are doing. For Ms. Hall's question, is air matter? There's many different ways you could have approached doing that investigation. Here's some possible manipulated variables that she could have chosen. Maybe she could have changed the balloon to see if there was a noticeable result instead of keeping it controlled. Maybe she could have changed the amount of air in the balloon to see if there was a noticeable result. And maybe she could have changed who was blowing into the balloon to see if there was a noticeable result. All of those are possible manipulated variables. The responding or dependent variable is the variable that results after you change or alter the manipulated variable. So here's those example manipulated variables from the previous slide. And here are some possible corresponding responding variables. So if we kept the manipulated variable as changing the balloon to see if there's a noticeable result, a possible responding variable would be the mass. Would the mass be different? If we had the responding variable be changing the amount of air in the balloon to see if there's a noticeable result, the possible responding variable that went with that one, will the volume of the balloon be different? And if we were to change who was blowing into the balloon to see if there was a noticeable result, maybe one possible responding variable would be, will the shape of the balloon actually change? So that covered what controlled, manipulated, responding variables are for a great lab investigation procedure. Let's look at the other components now. Good procedures always include an equipment and materials list, and there's difference between the two of those. First and foremost, equipment is defined as items that can be used again in the lab. For instance, beakers, graduated cylinders, hot plates, beaker tongs, flasks, all of those things can be washed and reused. Materials are defined as items that are disposable that we would throw away or recycle after the lab was over. So chemicals, disposable pipettes, paper towels, disposable face masks, maybe latex gloves, maybe vinyl gloves, all of those things would be thrown away after a lab investigation. If there are more than one piece of equipment or materials to be used, you need to include the quantities and the size of those pieces of equipment as well. So for instance, in this example, I have 3 250 milliliter flasks. So the quantity, the size, and the type of equipment used. Your procedure should be as clear as possible, which makes it really similar to one of your favorite baking recipes. So if you think about your favorite baking recipe, whether it's to make chocolate cake or pie or cookies, think about that baking recipe for a moment. Those recipes have a few things in common. One, good recipes always have clear instructions. When you read through the recipe, you know exactly what you need to do. Two, good recipes always have clear measurements. I'm going to use a 1/4 cup of olive oil. I'm going to use 1 egg. Very clear measurements. You're not always guessing what to put into the bowl. And last but not least, good recipes can be used over and over and over again, and you will get the same results most of the time if you don't mess up when you are performing that or you're baking with that recipe. So I think about it is if you can follow it again and again and again, 10 years later, your procedure or your recipe is clear. So how is a procedure for a lab investigation different than a recipe? So for a lab procedure, you must indicate how you are altering the manipulated variable. How is that manipulated variable being changed in order to see the responding variable? Here are those manipulated variables. Again, we had a previous slide as examples. And here are possible statements that you could use in your procedure to indicate how they would be changed during the course of the investigation. So if I was changing the balloon to see if there was a noticeable result, one thing I could say in my procedure is a red, yellow, and green balloon will be used. If I was changing the amount of air in the balloon to see if there was a noticeable result, I would state 5 milliliters, 10 milliliters, 15 milliliters, and 20 milliliters of air will be used. And if I was changing who was blowing into the balloon to see if there was a noticeable result, I would say 5 different people will fill up 5 of the same balloons. So those are statements that I would have put into that lab procedure to indicate how my manipulated variable is being altered. Last but not least, your procedure should require the scientists that want to refute or support your results to repeat the trials at least 3 times. So there's those possible alterations to the manipulated variable again. Here are statements that I could use to show that there will be at least 3 trials for every treatment of the manipulated variable. So if I was changing the type of balloon, I would say repeat 3 times for each different color balloon. If I was changing the volume of air in the balloon, I would say repeat 3 times for each volume of air. And if I had 5 different people filling up 5 of the same balloons, I would say repeat 3 times for each person. Those statements should be in there. I'm going to show you now an example of a procedure I wrote for Miss Hall's Is Air Matter lab. This is going to also be attached to this slide or this assignment in Schoology. You can definitely read through it, look at it as an example. I broke it up into a few pieces. So notice here, I started with my testable question, can we prove that airs matter? It's nice to break out the controlled, the manipulated, and responding variables outside of the written procedure. That makes it really clear for other people who want to repeat your investigation to know what you were controlling, what you were manipulating, and what was the responding variable. Right after that, I put equipment and I put materials. I only used one of each one of these things, so I didn't put quantities. After that, here comes my procedure. My procedure was 6 steps long. Notice in my procedure that I numbered the steps. Notice down below here, this is where we repeat altering the manipulated variable. I wrote this so that if I handed it to any person in the classroom, they would be able to perform the procedure without having to ask a lot of clarifying questions. So again, this copy of the sample procedure for Is Air Matter is going to be attached to this page, and it will hopefully help you when you write your procedure regarding figuring out why Diet Coke and the Coca-Cola phenomenon worked the way it did. So I hope you enjoyed. I hope it was educational. Thank you so much for joining me, and have a wonderful day.